Hello everyone. Today Aritra and my teammates Aditya and Mansi are here to pitch our project Multi-Agent AI for Emergency First Aid Assistance or Medical Assistance. So as we know that first aid is the immediate care given to individuals who are injured, but before the complete medical assistance arrives. So the systems we use for first aid delivery should be very fast and reliable. So these are some of the examples of the systems that exist for first aid delivery. So there are mobile apps. The challenge in mobile apps is that they provide very generic instructions without any personalization. And then there are voice assistants, which only deal with voice or textual inputs and outputs, and there are no context awareness. And then there are articles, online articles, which are very reliable, but the content there is very static, and in a emergency situation nobody would want to go through a article to know what to do, to find out what to do. So for research purpose we compared different LLMs to know what works best for the first aid context. So the common query we used across all these LLMs was a 6-month old baby is choking on a small toy and is unable to breathe. So the baby is unconscious and coughing weakly. So the expected response that we found in Indian Red Cross manual was giving it 5 back blows, then giving it 5 abdominal thrusts, and then calling ambulance if nothing works. So based on the information or the responses that each of these LLMs provided, we compared them across different aspects. So these aspects were cosine similarity, which was greatest for Llama 3, blue score, which was highest for GPT, clarity. In terms of clarity, uh, GPT and Gemini work the best. Safety, in terms of safety, GPT was the best, and in terms of completeness, each of these models lacks something or the other. So after reviewing all the work, all the significant work that has been done in this area, these are the major gaps we noticed. So the first one is the lack of real-time model, multi-model assessment. Means most of the models only deal with unimodal inputs or outputs, and they lack multi-model assessment. Then single model limitation, meaning most of the model lack the ability to distinguish between different levels of severity. Like they would treat a cut or a road accident the same way. So they can't prioritize their responses accordingly. Hallucination is another common problem where the responses look correct but are actually not. And this can be very dangerous in terms of medical assistance. And then lastly, no integration with real world resources. Like sometimes in case of emergency, the user would need something more than just textual guidance, which can be Google Maps or YouTube APIs, YouTube guidance videos. So to address all these gaps, our problem definition became to develop an AI-powered assistant, first aid assistant, that provides real-time medical guidance through multiple input methods, incorporating location-based hospital recommendations and severity assessment, depending on how severe your situation is. So now Aditya will explain the architecture of our project.
So let's begin by walking through the architecture of our intelligent triad system. The system starts at the user query, which can come in the form of voice, text, or image. Voice inputs are processed using Whisper AI for transcription. Image inputs are analyzed through Gemini Vision. Then all the inputs are funneled into a unified pipeline. The triad agent serves as a decision-making node. It uses BM25, a keyword-based retriever for text-based query, and also a face, a vector-based semantic retriever. The ensemble retriever is our core innovation, which combines these two methods to create a balanced score, optimizing relevance across modalities. The ensemble output is used to assess the severity of the medical issues. based on the computed severity score. Like it can be low severity or high severity. The low severity is routed to agent A, and the high severity is routed to agent B. So in agent A, we get the query, the YouTube video, and the solution we get is a little bit detailed as the user has time to read it because it is a low severity case. And in case of high severity, the steps are short because the response should be very short because we have less time, and also we get the nearby location of the hospital which where the patient can be taken. Both the agents query from the curated knowledge base, that is the Indian Red Cross First Aid Manual and the emergency first aid guides. Now let's zoom into the ensemble retriever, which is our main innovation. So why ensemble link? BM25 is robust for textual queries but lacks semantic depth. Face conversely captures semantic and visual nuances but may overlook keyword precision. Our ensemble approach combines both the strengths. So the best value for alpha was 0.3, which means 30% weightage to the BM25 retriever and 70% to the face. BM25 operates over the Indian Red Cross manual and face operates over the vector database. So to evaluate the ensemble retriever, we have used the NDGC score, which is the normalized discounted cumulative gain, to quantify the effectiveness of the ensemble retriever. Why NDGC? It evaluates how well the top K retrieved documents match the ideal relevance ranking, taking both relevance and position into account. So, so this is our real life testing. So we have taken this image on the iPhone and gave it to our triage agent. So it says that the image shows abrasions on the lower leg and knee of a male patient. The larger abrasion is located below the knee and the smaller is possibly deeper. So after image analysis, our agent says that it has a emergency of severity 2, like the severity is level 2. So for this, we have been given the steps like stop the bleeding, clean the wound, apply antibiotic ointments, cover the wounds, manage pain. Also, we have taken the same image on Moto G31, so which displays that irrespective of the image quality, the output of our agent is clear and accurate. So now Mansi will tell about the hypothesis of our project.
So, this hypothesis tests whether our severity assessment agent can accurately classify text based first aid queries. The null hypothesis assumes that the model's accuracy is less than or equal to 80%, meaning it's not reliable. The alternate hypothesis assumes the accuracy is greater than 80%, indicating it is effective. The 80% threshold was chosen as a baseline for acceptable performance in medical applications. On testing the model, we achieved 97.05 accuracy for high severity and 100% for low severity queries with an overall F1 score of 0.98. Since the performance clearly exceeds the 80% benchmark, we reject the null hypothesis and accept that the model is accurate and reliable for severity classification. The next hypothesis evaluates whether our model can classify injury severity from medical images. The null hypothesis states that the model's accuracy is 75% or less, implying poor performance. The alternate hypothesis claims that accuracy is greater than 75%, indicating effectiveness. We choose 75% as the threshold based on the added complexity of visual data and acceptable diagnostic standards. The model achieved 91.58% accuracy for high severity and 97.35% for low severity injuries, with an overall F1 score of 0.935. Since these results exceed the 75% threshold, we reject the null hypothesis and confirm that the model performs well in classifying injury severity from images. This hypothesis checks how fast our system responds to emergency queries. The null hypothesis assumes the average response time is 10 seconds or more, and the alternate claims it's less than 10 seconds. We choose 10 seconds as the threshold to ensure the system delivers timely assistance in emergencies. The system's average response time is 8.69 seconds for high severity and 4.37 seconds for low severity cases. Since both are well below 10 seconds, we reject the null hypothesis and conclude that the system responds efficiently. Following is the implementation of our project. This video shows the implementation of the text-based queries wherein a person is choking and the query is inputted. Since we get a 4 score of 4 for severity, the model provides shorter instructions, location of the nearby hospital, which can be accessed directly through Google Maps, and also the video instructions to help the person. This is the implementation with the image input being entered. Here the severity is 3, so we can get the future scope of our project is introducing continual learning techniques, language support in the voice interface for multilingual users, integrating wearable devices and health monitoring APIs to provide context-rich decision making. Thank you.